This video covers Section 3, Part 2, Caching with ElastiCache. Let's look at some of the terminology for ElastiCache. A node is a fixed-size chunk of secure network-attached RAM. A cluster is a logical grouping of one or more ElastiCache nodes. Each node runs an instance of the engine and version that you chose when creating the cluster. If necessary, you can scale the nodes in a cluster up or down to a different instance type. Every node within a cluster is the same instance type and runs the same cache engine. Each cache node has its own DNS name and port. Multiple types of cache nodes are supported, each with varying amounts of associated memory. Your application connects to an ElastiCache node or cluster by using a unique address that is called an endpoint. With the memcached engine, data is partitioned across nodes in a cluster. Memcached data is partitioned across up to 20 nodes. Memcached does not have replication. The Redis engine has additional components. As new functionality was introduced into newer versions of ElastiCache for Redis to support new Redis features, some component names were modified. The console reflects the updated terminology, but to preserve backward compatibility, the API and command line interface, CLI, use the earlier terminology. A Redis shard, which is called a node group in the API and CLI, is a grouping of 1 to 6 related nodes. If a shard has more than one node, the shard supports replication. In this case, one node is the read-write primary node, and the others are read-only replica nodes. A Redis cluster, which is called a replication group in the API and CLI, is a logical grouping of one or more shards. A Redis cluster configured without cluster mode always has one shard, and this configuration has no data partitioning. A Redis cluster configured with cluster mode can have up to 500 shards, and your data is partitioned across the shards. As a developer, you don't have to worry about actively managing ElastiCache after your cluster is up and running. ElastiCache is a managed service, so it handles administrative tasks like provisioning, failure detection, and software patching on your behalf. ElastiCache integrates with other AWS services, including Amazon Elastic Compute Cloud or Amazon EC2, Amazon Relational Database Service or Amazon RDS, and Amazon DynamoDB. ElastiCache also integrates with deployment management solutions such as AWS CloudFormation, AWS Elastic Beanstalk, and AWS OpsWorks. Therefore, you can focus on the application logic and not the infrastructure. Your focus as a developer is on writing the code to handle the following logical actions. The first is to request data from the cache. If you find the data in the cache and it has not expired, which is called a cache hit, the next step is to return it to the requester. If you don't find the data you need in the cache or the cached value has expired, which is called a cache miss, go to the third step and request the data from the origin. Then return the data to the requester, and as a last step, update the cache with the data retrieved from the origin. In this example architecture, Elastic Load Balancing distributes application traffic across multiple EC2 application instances, which are making external API requests. Numerous databases reading requests for the same data increases the response time, so you can add ElastiCache to improve response times and alleviate database pressure. The application reads from the cache. If the information is not available in the cache or is expired, the application reads from the database. This could be an Amazon RDS DB instance, DynamoDB database, or another database. If the database receives numerous read requests from the same data, the application writes the data received from the store to the cache. In this way, the data can be retrieved more quickly the next time it's requested. In the example with a cache miss, 3 trips are related to the request. You must send the initial request to the cache, query the database, and then update the cache. A cache miss can noticeably delay returning data to the application. One strategy is to load all data into the cache in advance rather than a subset. You might use this strategy if your application cannot tolerate the cache miss penalty for any request. Recall that a cache miss might happen if the desired value is not in the cache or the requested key has expired, meaning the time to live or TTL has expired. In addition to deciding what to cache, you must decide the TTL for data in the cache. A short TTL might result in more cache misses, but extending the TTL could mean you're returning stale data to your application. Cache expiration can get complex quickly. In a real application, a given page or screen often caches many different kinds of data at the same time. For example, profile data, top news stories, recommendations, or comments. Note that all of these could have different update methods. One strategy is to always apply a TTL to all of your cache keys. TTL is an integer value that specifies the number of seconds until the key expires. Test with production-like data and continue to monitor caching behavior and application performance in production. This strategy optimizes your choices for what to cache and how frequently it must be refreshed. Here are the key takeaways for this section of the module. ElastiCache is a fully managed in-memory data store with sub-millisecond latency. ElastiCache supports two open-source in-memory caching engines, Memcached and Redis. And a node is a fixed-size chunk of secure, network-attached RAM, and a cluster is a logical grouping of one or more ElastiCache nodes. That's it for this video. Thanks for watching, and we'll see you in the next one.